Hello all. As a continuation of the previous video, we will be discussing in detail about one clustering technique which is called as k-means approach. So this is the outline of today's video session. First, we'll be starting with an overview of what is k-means clustering. Next, we'll be continuing with the algorithm, how k-means clustering works, and an example scenario of the working of k-means clustering, an exercise, and finally we'll be summing up with the key points of k-means clustering algorithm. So what is k-means clustering? As we have already discussed, clustering comes under unsupervised learning methodology where there will be no predefined labels. We have to take the raw data set based on the similarity between any two documents. We have to make it under a single cluster. If the documents are not similar, we have to group it under two different clusters. So one of the technique under clustering is called as k-means. So it comes under partition based technique approach. So what is partition based approach? In the sense, we'll be having a set of documents. First, we randomly partition the documents to form clusters, and again we go for the second iteration to make or refine the clusters in such a way that each and every cluster's purity is at most to the target level. Here we say something called as k-means in such a word. So what is k? Is nothing but it is the number of clusters. Either some algorithms specify the required number of clusters, some algorithm doesn't specify. And the next one called as means is nothing but a cluster is represented by the mean value of the elements which is grouped inside it. For example, if three documents are grouped into cluster 1, we find the mean value of the documents and identify whether the clustering can be again refined or we can stop the clustering. That's why the name is called as k-means. So here this is working scenario. As I've already mentioned, either some algorithms may say what is k, some algorithms may not say. So initially, for example, if we say what is k, so k is nothing but the number of cluster, or it is also called as bins. The documents are initially assigned to the bins randomly. So randomly, if k is 3, we take 3 different bins, and if we take 10 documents, the documents are randomly given or initialized in or put in 3 different bins randomly. The documents are moved among the bins based on the mean value. So for the first iteration, we identify the mean value. If the mean value is not suitable for the first bin, we again iterate it. So the documents will be moved among those bins. An algorithm halts at local minima where the mean value will be at most matching with each and every document which is present inside the clusters. So this is an exact algorithm of how k-means works. So first, as I've already mentioned, we have to distribute all the documents among k-bins. So this will be done randomly. Compute the mean, which is called as summed centroid vector for each bin. So for this mean value, we take the features, feature vectors, we sum everything and divide by the total number of documents to get the mean value, and compare the vector of each document to each bin means to note then the mean vector that is most similar. So with an example, we can understand the third step in detail. So as an overview, in the third step, what we do is that we take each and every element of the cluster and we compare it with the mean. If the difference is okay, we keep it as such. If the difference is not okay, if it is too much, the difference is too much, long, we just move the particular item to some other cluster whose mean value is very near to the corresponding cluster's value, and move all the documents to at most similar bins. If no document has been moved to a new bin, then we can stop. Else, if some other changes has been encountered, then again the iteration has to be done once more by step 2. So this is an example. So here we have initial set of documents. For example, document ID is nothing but 0, 4, 2, 0 and 4. So these are nothing but document names. So initially what we do is that we say k is 2. So 2 in the sense 2 different clusters. We have to cluster these documents under 2 different clusters. So in step 1, we randomly cluster the first 2 different documents in cluster 1 and last 3 different documents in cluster 2. Now we identify the mean value of this. So like 0 plus 4 divided by 2, which is nothing but 4 by 2, 2. Here also we compute the mean value. Now we take all the particular documents and compare it with the mean value. So 0 and 2 somewhat matching, 4 and 2 is not matching, 2 and 2 is matching, 3 and 3 is matching well, and 4 and 3 matching well here. So 0 is kept over here. Document 2 has been moved from cluster 2 to cluster 1, and document 4, 3 and this 4 will be moved from cluster 1 to cluster 2. So here, because 4 is very much matching with mean value 3 rather than 2. And in step 2, again we compute the mean value to be 1 here. Here also the mean value is computed like so. And again, if we compare, the mean value after iteration 1 has been very much matching with the each and every document's mean value. So in step 3, the same documents are retained, no more changes has been done, so algorithm comes to a halt. So it converges after few iterations. So the efficiency of k-means algorithm is very good if the number of bins is very lesser than the number of documents. But if the number of bins, which is called as k, is increasing, the particular efficiency get decreased. The worst case complexity or the worst case problem or scenario can be when the number of bins is exactly equal to number of documents. For example, if I'm having 5 documents and if I say the number of bins, that is k is again 5, at most at a worst case, each and every bin will be having one document. So one document in one bin, resulting in comparing each document with each other. So this is a worst case scenario of k-means clustering. Now, as I've already mentioned in the previous video, after clustering has to be done, we have to label each and every clustering by means of cluster means. So, store a mean vector for each cluster and it's assigned a label from now on. So, here after the labeling has been done, so labeling will be done based on the cluster means. So, if you take the mean value, based on the mean value, the cluster document label will be identified. So, which particular document has exact equal to that of the mean value, the particular document's name will be kept as a label for the entire cluster. So after the cluster has been named, now our problem is equivalent to that of the classification problem, where we have a training data set, then which has a label. The particular label has been determined. Now our data set is equivalent to that of the classification or prediction problem. Now any new document is given, the particular document will be compared based on the similarity value as we have already done in the classification problem, and its label is identified. So the new label is assigned based on the maximum similarity level. So now we can go for the first exercise, where we are having a data like this. There is a medicine there are medicines A, B, C, D. Each and everything has a weight like 1, 2, 3, 5 and pH index 1, 1, 3, 4. Now the question is that we have to classify the above data set using k-means, where k will be equivalent to 2. So at most we are in need of 2 different clusters. So as I've already mentioned, as a first step, we have to say k equal to 2 and randomly group the items into 2 different clusters. For example, I'm taking cluster 1 and cluster 2. I'm grouping randomly document A and C inside cluster 1 and B and D inside cluster 2. So since it is happening randomly, we can also make A and B or A and D in cluster 1, the rest of the items in cluster 2. So after doing these particular random clustering, we have to identify the mean value. So this is how the mean value is computed. For example, if you take cluster 1, medicine A has 2 vectors, for example 1 and 1, weight and pH index. Similarly, medicine C has values like 4 and 3, weight and pH index. For these two values, we have to compute the mean. The mean is also called as summed centroid. Since it is mean, we will be adding the first two features together, 1 plus 4, and the next two features together, 1 plus 3, everything by 2. So it takes 2.5 and 2. Similarly, for cluster 2 also, we have to identify the mean as like 3.5 and 2.5. Now we have to identify whether is there any possibility to rearrange these items within cluster 1 and cluster 2, for which we take all the medicines, all the items, and we identify the difference, the mean difference with cluster 1 and cluster 2. So in my previous slide, we have already mentioned the summed centroid for cluster 1 is 2.5 comma 2. So here also we take 2.5 and 2. This is again the mean value which we have computed in the previous slide. Now we take first medicine's vector, we take the difference between its mean. So 2.5 minus 1, which is 1.5, 2 minus 1, which is 1, and again the difference over here. So when we see logically the two different values, we say this has minimum distance, so it is efficient to make medicine A under cluster 1. Similarly, if you take medicine B, identify the difference. Here it clearly says medicine B may belong to cluster 1. Similarly, if you take medicine C, the difference says that the medicine C can belong to cluster 2. Similarly, medicine D can also belong to cluster 2, because the first feature difference is 3.5 over here. Here it is simply 2.5. So this is a new identified group, so which is not matching with this. So the thing is that B is moved to cluster 1 and C is moved to cluster 2. So again the iteration may follow, and finally the clustering will be done based on the mean values. So as a summary, the particular clustering, k-means clustering, maximizes the similarity to the mean, but a small number of classes with high variance using means is simple. For example, if the number of classes, the clusters, is very simple, we can use k-means clustering. But if you take some other examples where the number of classes is larger, there it is going to have a poor results. K-means clustering will give you a poor results. And also fixing k. So what might be the k value, the initial, for example, what might be the number of clusters we are in? It is very crucial and most widely applied method for statistical clustering. And these are some of the reference. Thank you.